Yo, Caleb, I'm here to help you out with this simplifying square roots day 2. First thing I want you to see here, man, is that I really want you to do 14, 15, 17, 18, and 19. So some of these problems, I agree with you, they look really, really big and scary. I tried to pick the ones that were a little more manageable, although I understand they still might be difficult. So let's go ahead, let's take a look at number 14. This video might come to you in chunks as well. I'm only allowed to record 5 minutes at a time, so I might send you a couple of these depending on how they go. Okay, so number 14, you always want to look at this number inside first. That's your first step, man. So like all of these problems have a number inside. And what you're going to do is you're just going to look at how can I find two numbers that are going to multiply together to create whatever numbers inside of this square root symbol. And you can use a calculator, you can use your head, whatever works. So when I tell you these answers, it's because I know these because I've already done this. And you might take a few minutes to figure out these numbers yourself, and that's okay. So 45, I know, breaks down to a 9 and a 5. And I'm going to look at each of these numbers and I'm going to say, can I break apart either of these numbers into two numbers that multiply to make it? The 5 is done. There are no two numbers that multiply to make 5. You might be saying, yes, there are. It's 5 and 1. But that doesn't work. It has to be two, like, not itself. So the number can't be 1 and itself. So 5 is done. 9, there's more than just 9 and 1 that can make a 9, right? There's 3 and 3. And each of these 3's I need to look at and I say, can I break those apart? The only way I can break those apart is with a 3 and a 1. There's nothing else. There's no other combination. So then I'm done. So I've got a 3, and a 5 that are on the bottom of each of these trees. And so I'm going to rewrite the problem. This 5 is right here. Then I have a square root symbol. And instead of a 45, I'm going to write 3 times 3 times 5. All right? Because 3 times 3 times 5 is 45 if you multiply it all out. So why did I do that? Well, the reason why I'm doing this is because when I break it all apart like this, I want to find numbers that duplicate. I want to find numbers that exist as like a set of twins. And you'll see in this problem, I have these 3's exist in a group of 3's. And so I'm going to circle them. Now listen carefully, you might need to listen to this part multiple times. When I circle this group of 3's, they get to leave. These 3's get to leave, but when they come outside of the radical, they join together to create just a singular 3. So it's a pair of 3's that leave, but when they come out, they just create one 3. So I'm going to flop that 3 on the outside and multiply it to the 5. So it's not 35, it's 3 times 5. So where did this 3 come from? It came from this pairing of 3's that left to make 1. And also, if they left, just so you know, they don't really exist inside anymore. This 5 can't leave because they can only leave if they have a pair. It doesn't have a pair, so it cannot leave. So what do I do now? Well, I'm pretty much done. On the outside, I have 3 times 5, which is 15. And then I've got a square root symbol. And I've got a 5. This is my answer. Now you use a calculator to figure out what that is, but that's going to give you a weird decimal, so it's not going to work. I want your answers to be a number, a square root symbol, and then a number inside. That's it for this video. I'll send you another one.